Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is something a little bit different than what we usually do. We usually talk about specific concrete things about software development. Today I thought that in this week, perhaps we all need to discuss something a little bit different, something about aesthetics. And let me just show you what I mean. What I'm gonna talk about is, these are a few ideas that I've been thinking about for a while now, after reading a few books on general design and thinking about how general design applies to software design. And I came up with a few conclusions, which I would like to share. So what we'll talk about today is, first of all, does aesthetics play a role in programming? Second, how does aesthetics manifest in programming? And third, what about aesthetics in software design, software architecture, other things? And this will not be comprehensive, is going to be quite touching the surface. If you want to learn some more, let me know in the questions. I'd be happy to answer them. You know that we love comments, so please let us know. Ask questions, say if you agree or disagree. Yeah. First of all, first question, does aesthetics play a part in programming? And my answer is yes. As long as people are involved, aesthetics does play a part in programming. The way code looks, the way your tools look, even though it might not seem that important, it has influence upon your psyche, upon your motivation. So aesthetics actually plays a role. Now, how important a role? Well, I think software design, software development is closer to kind of factory industrial design in a way. Our tools tend to be more bare bones, more minimalistic, or our preferences maybe tend to go towards more minimalistic interfaces, things like that. But even in a factory, and even if you open up some of the best devices and look on the insides, typically they are well structured. They have a certain aesthetics. So perhaps we are not talking about aesthetics like in painting or like in art, right? But we are talking about the kind of aesthetics that applies to a more industrial context. And people have known for many years that having things, having a clean factory, having a well-organized factory, having some kind of structure, this helps with the factory, with the motivation and so on. But it also helps because it's aesthetically pleasing. Maybe everything is white, or maybe there are specific colors that mean specific things, but that come out in contrast with the others and so on. So maybe it might seem weird, but yeah, the way code looks, the way your tools look, the way your devices look, even though they are very minimalistic nowadays, these are all influences on your emotions, and in turn they influence your productivity because you can focus better. One thing that I found really interesting while studying this topic is there's discussion in architecture about the fact that a lot, I mean in building architecture, about the fact that a lot of the modern buildings have kind of clean edges and no protrusions. There's nothing showing up. It's like a very flat thing. And it turns out that there were some studies that from a psychological perspective, people naturally look for things to grab on. And when you do everything flat or seemingly flat, people, I mean, the brain interprets that as not having anything to hang on because everything around is flat. So one of the things with having decorations, for example, is that those provide a kind of psychological safety in the deep parts of our brain, because the brain interprets that as, okay, so if something happens, I can grab something, so I'm safe. It's better than not. So there are a lot of things like that that are not visible, that influence your emotions, and often you don't realize how they influence your emotions. I never thought before that, going around, I always felt weird around these flat modern buildings, but I didn't understand why. And it turns out that this is perhaps the reason. So now let's look at one example. And you have here in the center of the screen, you have a little bit of an ugly code that was created to be obfuscated. It was an obfuscation contest. It's written in Python, which is one of the languages that I give as an example for a clean, even beautiful, up to a point, programming language. It's not perfect, but it has a lot of aesthetics from my point of view. And look at this code and just focus a little bit on how you feel about it. Doesn't that feel like you cannot catch anything? Like you cannot grasp anything? Doesn't this give you a little bit of a reaction, a negative emotional reaction, saying, oh, geez, what is this? So beyond the technical aspects and so on, the first things that comes in play is your emotional reaction to that. And that emotional reaction can lead to other things. And this takes us to the next thing I like to talk about, which is a book by Donald Norman. Donald Norman is the person who fundamentally created usability as a principle with his books. And one of his seminal books is Design of Everyday Things. Now, maybe he didn't fully create, but he was definitely one of the contributors. Okay, I don't fully know the history of usability, but he is one of the most cited people in usability. And the initial book that talks about usability, Design of Everyday Things, talks about characteristics of an object in isolation. So characteristics of the designed object without taking into account the emotional aspects. But then he realized, look, there's actually a little bit more to talk about here. And we need to talk about emotions as well, and emotional design. And he describes 3 dimensions for emotional design. The first, visceral level, immediate initial reactions people unconsciously do and are greatly determined by sensory factors, look, feel, smell, and sound. And if you think about code, we basically have look. So we look at the code, we have a visceral reaction. Oh, this is cool, this is great, or what's with this fresh shell is this, you know. And Norman argued that attractive products work better because they can engage multiple senses to evoke emotional responses and bonds through use of visual factors of color, texture, and shape. He contends that beautifully designed products make people feel good. This is where appearance matters, and first impressions are formed, and the texture and surface of an object become important in evoking a specific emotional reaction. Thus, viscerally well-designed products tend to evoke positive emotions and experiences in the consumers. The second is behavioral level, which is all about use. What does a product do? What function does it perform? And here you might think that this doesn't apply to code, but think about it this way. You are a user of the code, of other people's code, of the code that is already there. You are using it. So what functions does that code already perform? And now your task is to add on top of those or to fix one of those. And this is where usability comes into play, and usable software design, a topic that I've discussed about before. Good behavioral design should be human-centered, focusing upon understanding and satisfying the needs of people who use the product. The third is reflective level to which the product has meaning for consumers, the emotional connections which are formed over time using the product that are influenced by cultural, social, personal factors. So this is also interesting because I've noticed a lot of developers who form an emotional bond with the code they wrote. I think this is less now in the age of mostly code that is not owned by a certain person, but collective code ownership. But before, when everyone was writing their own thing, it's easy to get into an emotional connection with it. And the picture here is also very interesting. This is the, let's see if we can find the actual name of the product. Philip Stark's Juicy Salif is an example. So this is basically a device that helps you juice oranges and things like that. And it has a specific shape, and that shape makes it interesting and makes it appealing. First, you see how it looks, and it might appeal to you or it might not. That's one of the things with emotions, right? They work on some people, they don't work, or they work completely differently on other people. But functionally, it does exactly the same thing as a much simpler, minimalistic juicer, but it just looks cooler. It's not something that, honestly, I would like to buy and have it in my home because I like more minimalistic stuff, but it definitely makes an impression. And that's, the visceral part. So now let's go back to our things and ask ourselves, how does aesthetics manifest in programming? Because I hope by now I convinced you that aesthetics plays a role in programming, as long as there are people involved. And I think we can talk about beautiful, or we can talk about ugly, because that's aesthetics. And basically, aesthetics is about two things that are kind of difficult to define, but I would say that some of them are definable, or you'd perhaps say it's more measurable in a more objective way, although, yeah, there is a bit difficult to talk about this. But there are certain traits that are definitely more specific or more general, or that you can point to. Things like symmetry, lack of clutter, harmony, things that make sense, that just click. But because we can define, we can analyze, we can come with descriptions of what makes those things more important. But the second one is undefinable traits, like it feels wrong. Maybe it's symmetric, maybe it looks harmonious, maybe the colors are right, but it just feels wrong. It just feels like something that doesn't match with me. And that's why it's a little bit difficult to discuss about these things, because often, programmers would associate, and there was a time when I was discussing about clean code and solid principles, giving a structure to the software design that is better. And developers would be pushing back and say, okay, it has to work. It's not about art. We're not making art here. Good enough. And back then I used to say, yeah, but art is about creating an emotional reaction rather than just functionality and a few specific things. And this is kind of where design is, right? Because I think it's wrong to ignore all the emotional aspects of design, including of software design. But it's also wrong to go all the way to the other side and say everything has to be symmetric, colorful, follow all these rules, and kind of forget about functionality. Functionality comes first, but then it helps it helps with the motivation of the people working with it. It helps with how likely it is to get new people working on those things if you have a more aesthetic approach to your code, to your software design. And it doesn't mean fully artful, right? Not as a masterwork, but more like an industrial style, like a factory style design, which is still a design, is still an emotional design. It's something that provokes a visceral reaction anyway, because you cannot avoid emotions. They are part of you. As long as you have people, you'll have emotions. As long as you have emotions, you'll have this visceral aspect. And that is unavoidable. It will be part of any type of design that you do, including code, including language, including tools for developers. So if we move further, we can, how does aesthetics manifest in programming? We can think about ugly code, ugly programming languages, or beautiful code, beautiful programming language. Ugly software design, beautiful software design. Ugly software architecture, beautiful software architecture. And for each of those, we can separate between these definable traits. Like software architecture is more beautiful if it has some guiding principles, for example. If it has some generative principles. Like maybe microservices architecture has a certain symmetry, right? You have things that kind of repeat themselves. It's more like a fractal kind of thing. And this is something that can be aesthetically pleasing. It makes your mind, it eases your mind because it's easier to grasp and to understand microservices than it is to understand different types of components. If you have different types of components, you need to come up with something more, something like maybe a metaphor or something that would help developers grasp those things better. So let's look at one part of aesthetics in one part of software development, and I'm going to look at clutter in programming languages. Now let's see some examples, because these are some of the things that I kept thinking about. And maybe I'm at a certain age when I want things to be nicer. I don't want to waste time with things that are not nice. So let's look at this first example. Person equals new person. This is clutter. It's a lot of clutter. I have to write 3 times the same thing. Okay, maybe the name of the variable can be different, but this is something that I've seen so many times, and it's just clutter. Now, newer constructs in programming languages, almost all of them have gone to do something like auto person equals new person, which is better. Yeah, I will grant that. Less clutter. But still, one of the reasons I like Python, person equals person of. And that's it. That's all you do. No def, no auto, no let, no other keyword. It's just variable initialized with a construct, with a constructor. It's as easy as that. Why do we need anything else? And compilers should be smart enough to figure this out by now. Also, please note another thing that I hate, that I didn't include here, semicolons. Semicolons are clutter. I don't need the semicolon after every one of my lines. I understand why we have them, but it's time to let them go. Okay, next one. Create person, receive some parameters, curly brace on the next line, then some code, then curly brace. Clutter, once again. It's clutter because it takes a lot of space, but it's also clutter because we'll see. So first, the next option would be to have the curly brace on the same line as the function definition. At least a little bit less clutter, but still there is some. Then the Python way, def create person, colon, and then you need to use tabs or spaces, doesn't matter, but it needs to have a certain indentation for the body of the function. So no curly braces. Now, many people say that this is wrong. I've seen a lot of people complaining about this, and fair enough, it's your visceral reaction. I'm okay with it, but to me, what I don't understand is, this is how we write text. Why is indentation not a problem in a normal text when you write something like this? But it is a problem in a programming language. I cannot understand that. You can definitely understand when you have a paragraph in a text that is indented. So this is not different from that. It's exactly the same thing. What's the problem? Okay, I can understand where the problem lies. If you have very long functions, then it starts to get a bit more complicated to understand what's going on. And maybe you can miss on the indentation. But the solution to that is, not Python is the problem. The problem is that you are having long functions. write shorter functions and you won't have any problem with indentation. At least that's what I think. Okay. And now let me propose you something else. How about we forget def, and I think we can even forget the colon, and use a heading style instead. Why are we still using in programming languages today the only possible style that we have? Why isn't it slightly rich text? And okay, could be markdown styled, you know, two sharp signs before, and that's it. Or hashtag signs, whatever you call them. And it's heading 2, and that's a function. Heading 1 is a class. Or heading 1 is the module, heading 2 is a class, heading 3 is a function. Why can't we have that? And you write it like that, and then what's funny to me is that your IDE anyway applies these kinds of styles, right? Only we don't write the code thinking that those are the styles. We think in terms of this is a function, this is a class. Why not think about it like this is a document and it has a heading and it has subheadings and it has some content? No, it's basically what code is. As far as I know, this is not done in any programming language, but it would be interesting to see. And the least cluttered approach. The other one, if condition, curly brace, return 6, semicolon, else, curly brace, return 200, semicolon, curly brace. Okay, lot of clutter. And to be honest, okay, there are ways to write this code so that is less cluttered, even in programming languages that require you to write things like that. That's fine. So you can, in many of them, you can remove the curly braces, you can write on a single line. So, but the safest way that I found is actually to use curly braces anyway, because sometimes you may miss something like in C++. If I remember correctly, you had to remember to use a semicolon someplace. I don't remember exactly, but there were some issues, right? I think it was even a bug related to that. Now, the way to reduce clutter that people have found here is to use this kind of sentence: return condition, question mark 6, colon 200, and then okay, semicolons. We can remove the semicolons. Now, what I don't like about this, it's less cluttered, so it's good. But now we get into a more interesting discussion. Perhaps, you know, clutter is not necessarily the length of the text. It's more like, again, how does this feel? And to me, this feels too opaque. So how about we do something like this? Return 6 if condition, else 200. I love this syntax in Python. Again, this is a Python syntax. It's great. It helps a lot. It's simple. You can read it like a sentence. Yeah, it's natural. And let's look at the last example. List of int values equals new list of int, of course. And then parentheses. And then values.add 100, values.add 20, values.add 300, values.add 40, and so on. And in case you don't see, there's a generative principle here. The odd numbers are multiplied by 100. So it's 1, 2, 3, 4, but odd numbers multiplied by 100, even numbers multiplied by 10. Now, the short version for this in many languages is auto values equals new list of int, and then you have some kind of curly brace syntax, 120, 340, and so on. Once again, Python and Groovy, and I think there are probably Ruby does something similar, is great. You can write things like values equal square bracket 120, 340, and so on. Awesome. And this gives us, the list is square brackets. I love that. You also have a separate syntax for tuples. You have a separate syntax for dictionaries. And I think this is just, it's how it should be. I don't need to write the type name, just I want to write the values. And then you can do this type of generative principle in Python, which is a list comprehension. It's basically values equals it times 10 if it is even, else it times 100 for it in range 1 to 5. This is again more verbose than what we had before, and you could replace you could use some functions and so on instead of writing the values themselves. But what I really love about this is that the way you can generate a list of values and do this. Now, is this the nicer than the one before? It depends on how many values you have. If you have 5, probably not. If you have 100, definitely. Yes, definitely better than what we had before. There's another syntax that I didn't catch here, which is the lambda syntax, but you can look at the different ways lambda is seen in is written. Lambdas can be written in various programming languages. And in this case, I think I like Groovy syntax the most. And that's the one I really like. But yeah, I think that's an interesting discussion, at least, to start with. And what I'd really like to see is smarter compilers that can deal with these kinds of things, that are more pleasing, nicer, more beautiful for programmers. Okay, now let's look a little bit at aesthetics beyond what we've discussed, software design and architecture. And I'm just going to launch a few ideas and leave the discussion open. Guiding principles, a few things that help with having a more aesthetically pleasing software design, software architecture. If you have guiding principles, if you show intent, if you use metaphors. Because these things point to a few things that we find pleasing. Symmetry. If you have some guiding principles, you then have symmetry. Microservices are basically very symmetric. Microservices with REST APIs, it's kind of what you expect. Now, do they fit all the possible use cases? No, of course not. But my belief is that one of the reasons why they caught so well is because of the visceral reaction that programmers had to them, which was generally positive. If you show intent in your code, in your structures, this points to care. Somebody cared about this. So, what's What's the visceral reaction when you see that somebody cared about it? You want to care a little bit more about it. That's nice. And the final one is, if you have metaphors, those are the equivalent of the ridges that you can grasp on, right? It's easier to understand. Because that's one of the things we are struggling with as programmers, trying to understand very abstract things. Okay, and with this being said, this has been today's, this is all I have for you today. It's about aesthetics in programming in general. I believe we need more aesthetics in our lives. And why not, better, nicer programming languages, better, nicer tools, better, nicer designs, architecture, and so on. So maybe, you should discuss not only about the technical aspects, but also about occasionally throw in how pleasing is this? Is this nice? What's the visceral reaction we have to it? Because it does matter. We are still humans. We are still influenced by our emotions, and we need to take them into account. Otherwise, don't be so surprised if people are not motivated. Okay, that's it from me today. What do you think about all this? Does it make sense? Do you see it? What visceral reactions do you have to various things? And in programming, how do you feel when you see your code from a year ago? Let us know in the comments. And if you have any more questions, if you want to explore a little bit more of these topics, let us know in the comments. We'll love to hear from you. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.